This is an example about aggregate expenditure model. This is our consumption function, which is C equal 1000 plus 0.7y. This is our investment function, which is equal to 500 plus 0.2y. Our government spending is equal to 700. X is equal to 100. Imports is equal to 100 plus 0.3y. So based on this one, we'd like to write our aggregate expenditure formula. So we know that our autonomous expenditure A bar is equal to C bar plus I bar plus G bar plus X bar minus M bar. Remember that some textbook, instead of putting a bar, which is a dash above each symbol, they put 0 beside it. So what do I mean by bar? It means that this is the number without the variable y. Therefore, we know that our autonomous expenditure is equal to 1000 plus 500 plus 700 plus 200 minus 100. And this will give us 2300. Then we need to calculate our multiplier. Our multiplier is equal to 1 over 1 minus little c minus little I plus little m. So remember, what do I mean by little c? This is our marginal probability to consume. If you look at the consumption function, this is the 0.7. Our little I is marginal probability to invest, and this is our 0.2. Little m is our marginal probability to import, which is 0.3. Therefore, at the beginning, we used all the numbers here just to calculate the autonomous expenditure, and then now we are calculating the multiplier. So our multiplier will be 1 over open bracket 1 minus 0.7 minus 0.2 plus 0.3. This will give us 2.5. Then our output at equilibrium, right here as y star, is equal to autonomous expenditure multiplied by the multiplier. So it will be 2300 multiplied by 2.5. This will give us 5750. The next step is, let's draw it. So in our x-axis we have our output, in the y-axis we have planned aggregate expenditure, and then our output line will be always 45-degree line. Why? Because now we draw our output at equilibrium, which means our aggregate demand or aggregate expenditure is equal to output, which means the value on the y-axis must be equal to the value on the x-axis, and that's why this line must be 45-degree line. Then we will draw our planned aggregate expenditure. So the formula of planned aggregate expenditure, which we just calculated, is 2300, which is our autonomous expenditure, plus 0.6y. This 0.6 is little c plus little I minus little m multiplied by output. And the point here is equal to our autonomous expenditure, which is 2300. If you look at the point of intersection between our planned aggregate expenditure and output, this is our output at equilibrium. And we calculate it as 5750, and it must be equal on the y-axis, which is 5750. Then let's assume that we will tell you that the government decided to increase its government expenditure by 100. So the change in G, the change in government spending, will be positive 100. It will go higher by 100. So my question to you is, based on the definition of the multiplier, if any autonomous expenditure increased, what will be the impact on output? It will be moving in the same direction. So if government spending will increase by 100, I know that our output will increase by more than 100 or equal to 100 or less than 100. It will be by more than 100. Why? Because we have the multiplier effect. It means that every time we have more economic activities, it will have a positive spillover on other activities. Consequently, the economy will grow at a faster rate. Therefore, always the change in output will be bigger than the change in autonomous expenditure. So we have two ways to calculate the impact on our output. The first one is the change in output is equal to change in A bar multiplied by the multiplier. So since change in G is part of change in A bar, therefore we'll say that our change in output is equal to 100, which is change in government spending, multiplied by multiplier 2.5. This will give us 250. So what will be our new output at equilibrium? So I write it here, y star 2 is equal to our original equilibrium, which is y star, plus a change in output, change in y. Therefore it will be 5750 as our original output, plus a change in output 250. This will give us 6000. And this is the first way. The second way is use the original formulas and update the numbers. So if we have a change in government spending by 100, we will calculate our new autonomous expenditure. So our new autonomous expenditure as a bar prime or dash is equal to our original autonomous expenditure plus any change in autonomous expenditure, which is the change in G in our example here. So I would say that our a bar prime or dash is equal to our original autonomous expenditure of 2,300 plus our change in a bar, which is a change in G equal 100. So this will give us 2,400. Then we know that the formula of our output at equilibrium is a bar multiplied by the multiplier. So now I write here our new output at equilibrium, which is y star 2, is equal to our new aggregate expenditure, which is a bar prime multiplied by the multiplier. Let's substitute. So it will be 2,400 multiplied by 2.5. It will give us 6,000. Can we calculate the change in output? Yes. Our change in output will be y2 star minus y star. The new output minus original output. The new output is 6,000 minus original output, which is 5,750. This will give us 250. And these are the two ways. And if you look here, we got exactly the same numbers for our new output of 6,000 and the change in output of 250. Now let's reflect the change in government spending on our aggregate expenditure graph. This was our original aggregate expenditure graph. Now we know that our autonomous government spending increased by 100. Therefore, our planned aggregate expenditure will have a parallel shift upward because we changed only autonomous expenditure. And our new autonomous expenditure will be 2,400 instead of 2,300. And our new formula of planned aggregate expenditure will be 2,400 plus 0.6y. Now we have a new point of intersection between our planned aggregate expenditure and output, this green point. And at this point, we will have a new output level of 6,000. And on planned aggregate expenditure is 6,000 because this is the equilibrium point. And as you see here, our government spending increased by 100. But if you look here, you'll discover that our output increased by more than 100. It increased by 250. Why? Because it increases by the multiplier. And in our example, the multiplier was 2.5.